Today's lesson is Module 2, Lesson 17, Divisibility Tests, and specifically for 3 and 9, but we will be going over all the divisibility rules. The very first thing I want you to do is actually skip this first page. We will come back to this page. On the next page, it wants us to go over or review divisibility rules. And we are actually going to put those in our notebooks. So if you go ahead and take out your notebook and put the title up at the top of the notebook, it's Module 2, Lesson 17, Divisibility Tests. And the reason why I want you to put this in your notebook, because I think you'll get more use of it in your notebook. So we're going to go over all of these divisibility tests, and you're just going to copy them into your notebook. The first rule that we're going to have is for the number 2. A number is divisible by 2 if and only if the number ends with 0, 2, 4, 6, or 8. Please remember that you can pause this video anytime to write these down if I go too fast. The next rule is for the number 3. If the sum of digits is divisible by 3, then the number is divisible by 3. And we're actually going to put examples of these in our book. For the number 4, a number is divisible by 4 if and only if the last 2 digits are divisible by 4. The rule for 5. If the number ends in 0 or 5, then it's divisible by 5. And then 6, if a number is divisible by both 2 and 3, then it's divisible by 6. We'll go on to the next page. For the number 8, if a number is divisible by 8, or a number is divisible by 8, if and only if the last 3 digits are divisible by 8. For the number 9, if the sum of the digits is divisible by 9, then the number is divisible by 9. And I skipped 10, and I should have put it in there. I'll go ahead and tell you what it is, and I will add it to the next page. So let's just do that now. For the number 10, if a number ends in 0, then it is divisible by 10. The next thing you need to know is that decimals and fractions do not follow the divisibility rules. So these divisibility rules only work on whole numbers. And then I have a couple other vocabulary words that we need to review before we get into today's lesson. And that first one is factor. And a factor are numbers that are multiplied together to get a product. So for example, 3 times 3 equals 9. The 3's are the factors. The 9 is the product or the answer. And then the last vocabulary word is the word multiple. A multiple of a number is a number that's multiplied by an integer. And I refer to this as skip counting. So for example, if you wanted to list the multiples of 2, then you simply skip count by 2's. 2, 4, 6, 8, 10, 12. So this is the same as saying 2 times 1, 2 times 4, 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6 result in those answers. So when you're talking about multiples, you're only recording the products. When you're talking about factors, you're only talking about the 2 numbers that you multiply together. So now let's go ahead and take back out our book, and we are going to, under the divisibility rules on page 80, we are going to actually write in some just examples. We first wrote out all of the divisibility rules, and I told you that we would put examples in here. So for the divisibility rule for 2, we said it was any number that ended in 2, 4, 6, 8, or 0. So if I have the number 12 and I divide it by 2, because it's an even number, I get the answer 6. So that shows that 12 is divisible by 2. The divisibility rule for 4. So for example, if I had the number 2,316, remember I only have to look at those last 2 digits. So I do 16 divided by 4, that gives me 4. I have no remainder. So that tells me this number 2,316 is divisible by 4. For the number 5, if I have the number 30, it ends in a 0. So I know that 30 divided by 5 is 6. So it doesn't matter as long as the number ends in 5 or 0. For the number 8, for example, if I have 5,128, for the number 8, remember we're looking at the last 3 digits of that number. So I do 1, 2, 8 divided by 8. How many 8s are in 12? 1. That gives me 8. Subtract, bring down my 8. How many 8s are in 48? 6. And I have nothing left, so it went in there evenly. So I know that 5,128 is divisible by 8. For the number 10, if I have 60, it's any number, remember, that ends in 0. So 60 divided by 10 gives me 6. I have nothing left over, so again, that works. The divisibility rule for 3, if you remember, we said for 3, if the sum of the numbers is divisible by 3, then the number is divisible by 3. So for example, if I have the number 231, then I add those digits, 2 plus 3 plus 1. 2 plus 3 is 5 plus 1 more is 6. So 6 divided by 3 gives me 2. I have no remainder. So that means 231 is divisible by 6, or is divisible by 3. The divisibility rule for 9, again, we're going to add all of the digits together. So if I have the number 6,723, the first thing I'm going to do is add those digits together. So 6 plus 7 is 13, plus 2 more is 15, plus 3 more is 18. I divide that by 9. 9 goes into 18 2 times with nothing left over. So that tells me that 6,723 is, in fact, divisible by 9. So now we're going to go on in the lesson, and we're going to do a couple of examples together. In this first example, it wants us to look at our divisibility rules for 3 and 9. And the first task that it has us do is expand 378. So when I write 378 in expanded form, that is the same as writing 300 plus 70 plus 8. And then I can break it down further as 300 is 3 times 100. 70 is 7 times 10. And then I can leave my 8 the way that it is. The next thing they want us, I guess I could just leave the 8 here, and then we would be adding those two numbers together. The next thing they want us to do is to decompose that expression that we wrote. So if you remember, I had 3 times 100 plus 7 times 10 plus 8. So they want me to decompose this 100. So I can do 3 times 99, sorry, 99 plus 1 plus, I'm going to decompose this 10, 7 times 9 plus 1, and then I'm going to leave my 8. So that's the same as 3 times 99 plus 3, because 3 times 99 and then 3 times the 1 gives me my 3, plus 7 times 9 plus 7 plus 8. Then it wants me to factor in the 9. So 3 times 9 times 11, because I'm splitting this 99 now, plus 3 plus 7 times 9 times 1 plus 7 plus 8. And finally, I get the result of 9 times 3 times 11 plus 7 plus 3 plus 7 plus 8. When I add these digits together, 3 plus 7 plus 8, I get 18. And it wants to know, is 18 divisible by 9? Yes. So is the number 378 divisible by 9? Yes, because the sum is divisible by 9. Is it divisible by 3? Is 18 divisible by 3? Yes, because the sum is divisible by 3. And that example just proves to you why the divisibility rule of 3 and 9 work. You are not ever going to have to prove that again. We just walked through that to just show you how that works. You are not going to do example 2. You and your partner are now going to get together and you are going to do exercises 1 through 5. It continues on to the next page. And what you're going to do is you're going to check the divisibility rules for 3, 9, and 4 against that number 2,838. So you want to know, is this number divisible by 3? Is this number divisible by 9? Is this number divisible by 4? If it's divisible by 3, then you simply circle the 3. If it's divisible by 9, then you circle the 9. If it's divisible by 4, then you circle the 4. And you're going to do that whole thing with a partner. So go ahead and pause your video, work those out, and then you can come back and check your answers. So let's go ahead and check your answers. So for number 1, you should have marked that 3 was divisible, because when you add all those digits together, you get 21, and 3 goes into 21 7 times. You should have said that 21 is not divisible by 9. And then the last 2 digits, 38, 38 is not divisible by 4. On to number 2. When you add the sum of those numbers, you get 18. 18 is divisible by both 3 and 9, so both of those are circled. And then the number ends in 5, so that tells me it's also divisible by 5. For number 3, when you add the sum of those numbers, you get 21. So again, 3 is divisible by 21. 21 is not divisible by 9, and then this number is odd, so it's also not divisible by 2. go on to your next page, you should have said that 3, 9, and 10 are all able to be divided into 4,320, because when you add those digits together, you get 9, and 3 goes into 9 3 times, and then 9 goes into 9 1 time, and then the number ends in 0, so I also know it's divisible by 10. And for the last one, you should have circled 3 and 8. When you add the sum of 6,240, you get 12. 3 goes into 12 4 times, but 12 is not divisible by 9 without a remainder. And then when I look at this number 6,240, and when I just check those last 3 digits to see if it's divisible by 8, I can see that 8 goes into 240 30 times. So that makes 8 also a factor of 6,240. So for today's problem set, you are only going to do 4 and 5. So you're going to skip 1, 2, and 3. You're going to only do 4 and 5. So for number 4, you're going to write a 3-digit number that's divisible by both 3 and 4. And for number 5, you're going to write a 4-digit number that is divisible by both 5 and 9. And then you'll go on and do today's exit ticket. If you have any questions for me, please let me know.